OK, last topic in DNSSEC before we're all done is the idea of signing non-existent domains. It's a little edge case, but it leads to some creative design decisions. So far, we've been talking about verifying records that do exist. When I ask for the IP address of eeks.berkeley.edu, I get an answer, and I'm able to verify that the answer is correct, but hasn't been tampered with. But one edge case we haven't talked about is users querying for domains that don't exist. What if I try to ask for the IP address of fake1.google.com? We know that's not a real IP address, or it's not a real domain. Google doesn't have a domain or an IP address corresponding to that domain. So how does DNSSEC deal with the fact that this domain doesn't exist? There's a couple options. One option is to not do any authentication on these responses. So if you ask for a non-existent domain, then the server would just reply saying, sorry, the domain you asked for doesn't exist, and don't sign it at all. So that's one option. But if you're not signing it, then somebody could spoof a non-existent domain response. Suppose you ask for the IP address of eeks.berkeley.edu, and an attacker, like a man in the middle, dropped the legitimate response and replaced it with a does not exist response that says eeks.berkeley.edu does not exist. If we don't do any signing on these responses, an attacker could trick the user into thinking that eeks.berkeley.edu doesn't exist, even though it actually does. And you could use that for something called the denial of service attack, which we'll see later. So that's one option. Don't do any signing on these non-existent responses. Downside is that you leave yourself vulnerable to attacks. So what's the other option? The other option is to actually sign every response for a non-existent domain. But this actually has performance issues. So one big performance issue is that signing is slow. We've already seen that public key cryptography takes time. It's not trivial to generate a signature. So if an attacker or if a user tries to ask for the IP address of fake1.google.com, the name server has to generate the signature and then send it back to us so that we have a signed response saying that fake1.google.com doesn't exist. So there is some performance impact. The name server now has to sign every single non-existent domain response. So maybe your follow-up idea is to use caching. Can we just have the name server sign all of the domains ahead of time so that it doesn't have to sign every single time someone requests it? For existing domains, that's no problem. If Google has 20 subdomains, we can just sign all 20 records ahead of time. And anytime someone asks for one of the 20 existing domains, you just return the corresponding signature, and you don't have to re-sign records on demand. That works for existing domains. What about non-existent domains? How many non-existent domains are there? Fake1, fake2, fake3, and any other string you can think of that doesn't exist. There's infinitely many non-existent domains. There's probably some limit on how long a URL can be, but we're looking at an enormous number of non-existent domains. Trying to make a signature for every single non-existent domain and caching all of those ahead of time is just not feasible. You'd have to write out every single possible string. That's no fun. So our only options, if we wanted to sign non-existent domains, are to either sign on demand. When someone asks for a non-existent domain, we waste some time signing and then send it back. Or we sign everything ahead of time, which is just impractical. So neither of these options seem so good. Option number one has attacks that are possible. Option number two has performance impacts. And it also has a security impact that we'll talk about later. But neither of these seem so good. What we really want is some way to prove that a domain doesn't exist without having to sign on demand, because signing on demand is slow. So this is the problem that we're faced with, and the solution, you can try and brainstorm it ahead of time, is actually kind of clever.